Hello, and welcome to the lesson on application of Pythagoras theorem. The three things that we are going to learn in this lesson are, first we'll understand how do we calculate the missing side of a right angle triangle using Pythagorean triad. Then we'll go on to find how do you find the missing side of a right angle triangle using the Pythagoras formula. And finally, we'll understand the application of Pythagoras theorem in real life situations. So let's begin then. So how do we use Pythagorean triads to find the value of the hypotenuse, this length of the hypotenuse in each of the three triangles? Now, just to remind you, what are Pythagorean triads? Pythagorean triads are a set of three numbers which can form the lengths of sides of a right angle triangle, correct? And hence, these are the three values which follow Pythagoras theorem. Now, the interesting property that we had learned in the earlier class was any multiple of a standard or basic triad gives you another triad. And we'll be using this particular property to find the missing sides of any right angle triangle. For example, if I take the second triad and multiply each value of that triad by 2, what will I get? I'll get 5 times 2, which is 10, 12 times 2, which is 24. And as you can see, the two perpendicular sides of the first triangle on the left are 10 and 24, which means to find the hypotenuse, all I need to do is 2 times 13, which is 26. So just a reminder, I had asked you to remember these triads very well, right? So you need to know these basic triads in order to find the missing sides of a right angle triangle using the method of Pythagorean triads. So the basic triads are 3, 4, 5, 5, 12, 13, and 8, 15, 17. For example, if you look at the second triangle, the two perpendicular sides are 30 and 40, which you can easily link to the first triad on the left, 3, 4, 5, because all I need to do is multiply that triad by 10. If I multiply each value of the triad by 10, I'll get 30 and 40, which are the two perpendicular sides, and hence the hypotenuse has to be 5 times 10, which is 50 units. Right? Finally, let's come to the last triangle. One of the sides is 30, the other side is 16, and a little thought will tell you that, okay, we need to link it to the last triad, 8, 15, 17. Because if I multiply each value of the triad by 2, I will get 8 times 2, which is 16, and 15 times 2, which is 30, which are the two sides of the triangle which is shown here. And hence, the hypotenuse has to be 17 times 2, which is 34. See how easily we can find the missing side of any right angle triangle using this technique of Pythagorean triads. So here are 6 more triangles. In each of these triangles, the hypotenuse is missing. Can you use the basic triads which are given on top to find out the missing hypotenuse in each of these triangles? You can pause the video at this moment if you want and give it a thought. Well, now if you look at the first triangle, we have 30 and 72. So look at the 3 triads on top and figure out which triad can you link 30 and 72 to be. As you can see, in the second triad, which is 5, 12, and 13, if I multiply each of these values by 6, I should get 5 times 6, which is 30, and 12 times 6, which is 72. So the missing side of that triangle, the hypotenuse, has to be 13 times 6, which is 78 units. Let's look at the second triangle now. The two perpendicular sides are 27 and 36. You can easily say that one of them is 9 times 3 and the other one is 9 times 4. So we can link it to the first triad, which is 3, 4, 5. If I multiply each of those values by 9, I should get 27, 36, and hence the missing hypotenuse has to be 9 times 5, which is 45. If you look at the third triangle, you'll realize that the third triad has to be multiplied by 3. So I get 8 times 3, which is 24, 15 times 3, which is 45, and hence the hypotenuse which is missing has to be 17 times 3, which is 51 units. What can you say about the fourth question, the triangle in the fourth question? The perpendicular sides are 24 and 18, right? Now, if you look closely, it's again linked to the first triad. If I multiply the values of the first triad by 6, you'll get 3 times 6, which is 18, and 4 times 6, which is 24. These form the two perpendicular sides, and hence the hypotenuse which is missing has to be 5 times 6, which is 30 units. Let's go to the next triangle. We have two sides which are 32 and 60, and if you look closely, okay, both of them are multiples of 4, correct? One is 4 times 8, the other one is 4 times 15. And hence we can link it to the third triad up there, 8, 15, 17. If you multiply each of them by 4, you will get 32, 60, and hence the missing hypotenuse has to be 17 times 4, which is 68. And finally, the last triangle has perpendicular sides 60 and 25. You can link it to the second triad, because if I multiply each value of the second triad by 5, I would get 5 times 5, 25, 12 times 5, 60, which are the two perpendicular sides. And hence, the hypotenuse which is missing has to be 13 times 5, which is 65 units. Well, now let's use the same technique of Pythagorean triads to find one of the missing perpendicular sides, given the hypotenuse. Now, this is easier than the task that we did earlier. The reason being, I know that the longest side of a right angle triangle is hypotenuse. And since I know the hypotenuse, I can easily link it to one of the triads. For example, in the first triangle on the left, we can see that the hypotenuse is 20 units. Now, if you look at the three triads up there, the last value corresponds to that of the hypotenuse, right? Because it's the biggest of the values. So if I look at it, 20 is a multiple of 5, correct? And hence we can easily link that triangle to the first triad. All I need to do is multiply the hypotenuse by 4. 5 times 4 is 20. And then I realize that the other side which is given is 3 times 4, which is 12. So the missing side has to be 4 times 4, which is 16 units. Let's try this again with the second triangle, the one on the right. As you can see, the hypotenuse is 52 units long, and 52 is a multiple of 13. So I can easily link that triangle to the second triad. 13 times what gives you 52? Well, it's 13 times 4. Then I realized that the middle value of that triad, which is 12 times 4, will be 48. So the missing side has to be 5 times 4, which is 20 units. Right? Now use this technique to find the missing side of each of these right angle triangles. For your reference, the triads are given on the top. Try using the technique of linking the length of the hypotenuse to one of these triads. You may choose to pause the video at this moment in order to have a go at these questions. Well, let's look at it. The first triangle has a hypotenuse of 39, and 39 is a multiple of 13, and hence we can link it to the second triad. 39 is 13 times 3, so the multiplication factor is 3, right? 5 times 3 is 15, which is the other side which is given to us, and hence the missing side should be 12 times 3, which is 36 units. Let's look at the second triangle. The hypotenuse there is 35 units, and 35, as you know, is a multiple of 5, so I can easily link it to the first triad. 5 times 7 is 35, and hence the multiplier is 7. 4 times 7 is 28, which is the other side which is given to us, and hence the missing side has to be 3 times 7, which is 21 units. If you look at the third triangle, the hypotenuse is 68, which is a multiple of 17. So we can link that triangle to the third triad. 17 times 4 is 68, and 8 times 4 is 32, which are the two sides that is given to us. And hence the missing side of that triangle has to be 15 times 4, which is 60. Now, look at the fourth triangle. The hypotenuse in that triangle is 51 units, which is once again a multiple of 17. So we can link that triangle also to the same triad 8, 15, 17. But this time the multiplier is 3 because 17 times 3 is 51. And we also know 15 times 3 is 45. So the missing side of the triangle should be 8 times 3, which is 24. The next triangle has a hypotenuse length of 65, which is a multiple of both 5 and 13. So let's link it to one of these triangles by looking at the other side. Okay, the other side is 60. 60 is 12 times 5. So we can link it to the second triad. The multiply is 5 this time. So 13 times 5 is 65. 12 times 5 is 60. So the missing side of that right angle triangle has to be 5 times 5, which is 25 units. And finally, if you look at the last triangle, the hypotenuse is 55, which is clearly a multiple of 5. And hence we can link it to the first triad. And the multiplier there is 11. 5 times 11 is 55. 4 times 11 is 44. So the missing side of that triangle has to be 3 times 11, which is 33 units. So we have used the triads to find the missing side of any right angle triangle quite easily. Now, let's understand how do we use the Pythagoras formula to find the missing side of a right angle triangle. Now, if you remember, the Pythagoras formula states if you square the lengths of the two sides which make up the right angle and add them, you will get the square of the hypotenuse. So in this triangle, the two sides which make the right angle are 5 and 10. So all you need to do is you need to square each of those values, which is 5 squared and 10 squared, add them up. So 5 squared plus 10 squared, and that should give you the square of the hypotenuse, which is c squared. 5 squared is 25, 10 squared is 100. So c squared has to be 125, or c has to be square root of 125, which is same as 11.18 units rounded to 2 decimal places. And that's your answer. Let's use the same formula again for the next triangle. In this case, the two perpendicular sides are 17 and 19. So the formula is hypotenuse squared, which is c squared, should be equal to 17 squared plus 19 squared, the sum of the squares of the two sides which make the right angle triangle. Okay, 17 squared is 289 and 19 squared is 361. If you add them, you get 650. So c has to be square root of 650, which is 25.50 units rounded to 2 decimal places. Right. Now here's some for practice. In each of these right angle triangles, you need to find the length of the missing hypotenuse. And you need to give your answer to round it to 1 decimal place. Right? You may use your calculator if you want, and pause the video at this moment in case you want to give it a try. Well, in the first case, the two perpendicular sides are 2 centimeters and 9.9 centimeters. So x will be nothing but square root of 2 squared plus 9.9 squared. In this case, the answer is 10.1 centimeters. Remember, we need to round the answer to 1 decimal place. In the second question, the two perpendicular sides are 8.5 and 13.2, and hence the hypotenuse, which is x, has to be square root of 8.5 squared plus 13.2 squared, which is 15.7 centimeters. In the third triangle, once again, the hypotenuse is x and the two perpendicular sides are 140 meters and 51 meters. So the value of x will be square root of 140 squared plus 51 squared, which is 149.0 centimeters rounded to one decimal place. In question D, the two perpendicular sides are 52 meters and 165 meters. And hence the hypotenuse, which is x, will be square root of 52 squared plus 165 squared, which is the same as 173.0 meters. That's a typo. It should be meters, not centimeters. And finally, in the last triangle, which is A, the two sides which make the right angles are 11.9 kilometers and 12 kilometers. And hence the hypotenuse, which is x, will be the same as 11.9 squared plus 12 squared, which is equal to 16.9 kilometers. Once again, there's an error in the units. It should be 16.9 kilometers. Well, now how can we use the Pythagoras theorem to find one of the perpendicular sides which is missing? So given the hypotenuse, how do we find the length of one of the perpendicular sides? So we'll apply the Pythagoras theorem as a normal way. So if I square each of the perpendicular sides and add them, I should get the square of the hypotenuse. In this case, the hypotenuse is 13. So 13 square should be equal to 11 squared plus x squared. 13 squared is 169, 11 squared is 121. So x squared will be 169 minus 121, which is 48. Or x will be equal to square root of 48, which is 6.93 centimeters rounded to two decimal places. What about the next question? In the next question, as you can see, the hypotenuse is 9 centimeters because that's what is opposite 90 degrees. So if I apply the Pythagoras theorem for that particular question, I would get 9 squared, which is the hypotenuse square, should be equal to 4 squared plus x squared. 9 squared is 36. Oh, sorry, 9 squared is 81. My bad. 4 squared is 16. So x squared will be equal to 81 minus 16, which is 65, or x would be square root of 65, which is 8.06 centimeters, rounded to two decimal places. Now, when do we know we have to add square and add, or we have to find the difference of the squares? Okay. So if the hypotenuse is missing, then you use the normal formula, which is with addition. Okay, so square root of a squared plus b squared, where a and b are the lengths of the two perpendicular sides. So to find the value of the hypotenuse, which is missing, you use the plus formula, square root of a squared plus b squared. On the other hand, if one of the perpendicular sides is missing and you're given the hypotenuse, then you will use the formula with the subtraction. It will be square root of c squared minus a squared, where c is the hypotenuse and a is the given or the known perpendicular side of the triangle. So make sure you understand this, because this is where a lot of you will get confused. When do we add and when do we subtract? Correct? So if the hypotenuse is missing, you square the remaining two sides and add them. If one of the perpendicular sides is missing, you square the hypotenuse and minus it, okay? Minus the square of the perpendicular side that you are aware of or known. Right, okay, here are 4 questions. Use your calculator and you can pause the video at this moment if you want, and you can give it a try. Okay, find the value of the missing missing perpendicular sides of the right angle triangle in each case. Because one of the perpendicular sides is missing, we'll use the formula with the subtraction. So the first one would be square root of 17 squared, which is the hypotenuse squared, minus 12 squared. And hence the answer is 12.0 rounded to one decimal place. In the second case, the hypotenuse is 13. And hence A will be equal to 13 squared minus 9 squared, which is 9.4 units. In case of the third triangle, the hypotenuse is 18, and hence B, which is the missing side, will be equal to 18 squared minus 11 squared and square root of that, which is equal to 14.2 units. And finally, in the last triangle, the hypotenuse is 15 and one of the sides which is given is 8. So your missing value, which is A, will be equal to square root of 15 squared minus 8 squared, which is the same as 12.7 units. Now, make sure that you understand when do we add and when do we subtract, because that's the only place where you might end up going wrong. Now, let's try and find the application of Pythagoras theorem in real life situations. A farmer has a rectangular field and must walk from one corner to the opposite corner to get his tractor. How far is this? Right? So here's the diagram given to you. So you need to find out how far does he walk. Okay, and the rectangular field has a length of 60 meters and a width of 45 meters. As you can clearly see, the diagonal of the rectangle with the two perpendicular sides end up becoming a right angle triangle, correct? Which is right angled at that corner. And hence, if I apply the Pythagoras theorem, the hypotenuse which is missing, because the distance that he travels to reach his tractor would be the hypotenuse of the triangle. And that is equal to square root of 45 squared plus 60 squared, which is 75 meters. And that's the distance he needs to travel to reach his tractor. Okay, here's your next question. A ladder of length 5 meters leans against a vertical wall. The foot of the ladder is 4.2 meters from the base of the wall. How far is the top of the ladder from the ground? Now you need to visualize this picture. So we have a ladder which is resting against a wall and there's a floor as well, something like that, right? As you can see, the foot of the ladder is 4.2 meters from the base of the wall. So that horizontal distance from the base of the wall to the foot of the ladder is 4.2 meters. And the ladder itself has a length of 5 meters. So the hypotenuse of that right angle triangle is 5 meters. And in this case, we need to find, okay, how far is the top of the ladder from the ground? So the height is what we have to find, h. Because h is one of the missing the sides of the perpendicular sides of the right angle triangle. It's one of the perpendicular sides of the right angle triangle. And we know the hypotenuse. We'll use the formula using the minus sign, correct? So h will be given by square root of 5 squared minus 4.2 squared, which is the same as 2.7 meters rounded to 2 decimal places. Right. And finally, let's look at this question. A boat sails due east from a harbor H to a marker buoy B 15 miles away. At B, the boat turns due south and sails for 6.4 miles to a lighthouse L. It then returns to the harbor, taking a direct route. What is the total distance traveled by the boat? So first, let us visualize the diagram, right? So as you can see, from a harbor H, the boat is moving due east to a buoy, which is 15 miles away. And then from there, B, it goes due south, which is 6.4 miles. And then from the lighthouse to the harbor, it takes a direct route. And as you can see, this is again a right angle triangle, which is right angled at B. And since the hypotenuse is missing, our first step is to find what is the distance which it travels during the return journey, which is the hypotenuse of this right angle triangle. For finding the missing value of the hypotenuse, we'll use the formula using plus. So LH, which is the distance from the lighthouse to the harbor, would be equal to square root of 15 squared plus 6.4 squared, which is 16.31 miles. But the question is not to find LH. The question is to find the total distance traveled by the boat in this round journey. So the total distance traveled by the boat will be 15 plus 6.4 plus 16.31, which equals 37.71 miles. So these were some of the applications of Pythagoras theorem, and that brings an end to this lesson. Remember, we studied three things in this lesson. First, we found out how do we find the missing sides of a right angle triangle using Pythagorean triads. Then we understood how do we find the missing sides of a right angle triangle using the Pythagoras formula. And remember, when do we use the plus formula and when do we use the minus formula? And finally, we also looked at some of the real life applications of the Pythagoras theorem, right? I hope you understood the concepts which are taught in this lesson. I enjoyed bringing it to you. Thank you.